Hi and welcome everybody. It's really a great pleasure to be here with you in such a great event, Belgrade. Today I'm going to talk about an API, a view model API we developed in our projects in order to solve several problems arising when persistent domain objects are directly bound to UI components in our enterprise projects. Before delving into details, let me first introduce myself briefly. My name is Kenan Sevindik, coming from Turkey. I have over 15 years of experience in enterprise application development. Actually, I started playing with Java in 1998 with Java applets. Since then, I have been involved in various applications, enterprise application development projects, have extensive knowledge about various enterprise Java technologies like Spring Security, Hibernate, Vaadin, etc. Last year, we published a book called Beginning Spring. I am a co-author of that book. Also founded Harizmi IT Solutions located in Turkey in 2011. And we mainly develop enterprise software, offer some consultancy, and organize public and private trainings like Spring, Hibernate, object-oriented programming, design patterns, Vaadin UI framework, etc. Now, let's come into our problem. I will try to explain the problem by giving several examples, one by one. Also, switch to the idea to show how such problems occur and data integrity problems arise. Our problem is that several problems actually arise in case persistent domain objects are, which are fetched by JPA or Hibernate and directly bound to UI layer. Let's start with our scenario one. Here, I actually borrowed a small portion of domain model from infamous pet clinic project. We have owner and his pets also, and their association between owner and pets are lazily defined. Here, first, in the owner list view, several owners are listed, and one of them is selected, and edit owner button is clicked by the user, and owner detail view is shown. Here, our user performs some changes in the owner detail, but without clicking on the Save Changes button, it just presses Owner Pets tab. In the owner's tabs, owner pets, in order to list owner pets, detached owner entity here is reattached to the JPA persistence context using merge method. At that point, however, those changes performed previously just reflected into database and persisted. Let me show this in a working example. Let's start our project. Before starting it, let me just show you the domain. Here is the owner. It just extends from pet, has first name, last name, so simple, and its email. We will just focus on that part. Now, starting the project. I have actually two paths, one to show you the problem and the other for to demonstrate our solution. Here, let's go through the first one. Here, two owners, sample owners are just listed. We click edit button and perform some change. At that point, when we clicked to pets tab, if you look at the console, we will see that an update performed. This is because of the operation. Let me show you in the backing bin. Here, when the tab is switched, that method is just changed and owner is merged to reattach the detached owner to the person's context so that lazy pet association could be initialized, fetched from the database. Indeed, if we look at the database, sorry. Here's a little debugging session to just see that. As you see, data is just modified in the database. Owner is just modified. If we overview this scenario, lazy association should have been handled its own without causing any data modification in the database. Any changes performed on the detached owner entity should not have been reflected into the database as a side effect of this lazy handling association. Let's come into our second scenario. Again, we start with the list view, list several owner entities, select one, and click edit owner button. Now, again, we are in the detail view. Here, we perform some changes, and again, without clicking save changes, click owner pets tab. In the owner pets tab, several pets are just listed. We select one and click edit pet button. Here, just edit pet dialog appears and user modifies several properties of that pet and click save changes button. Regarding depending on the cascade definitions defined between owner and pet association or attachment status of the owner entity, changes again might get reflected into the database. Let's see this in action. Actually, I will just follow a little bit different path because we already cause a reattachment when we just presses the Pets tab, but we will have the same end result. Here, I just modify again owner first name, click Pets tab, edit pets, and perform a modification in the pets name, but just decide to cancel the operation instead of committing it. Unfortunately, if we again look at our database, Sorry. Something wrong. Oops. Let's start. Beginning. This one. We are in the paths and save. Click cancel. Now open. Oops. Actually, the name of the pet entity should have been modified. In that case, I couldn't figure out why it didn't happen right the moment. Anyway, let's just start the application again. The modification should have been because of the association is just defined as cascade all operations performed. Sorry, I just figured out. I just executed the scenario on the halfway. Just stopped. Okay, I just realized what was the problem. Yes, it just started. Again, we enter into our scenario. Let's change this one and go to pet detail here. Perform some change, cancel, and switch back to owner detail. Do some thing and sorry. Here we just attempt to save owner. When we attempt to save owner, changes performed in the pet entity also reflected into the database. Let's check the database. Again, here you see that the name of the pet entity was just changed. Here, changes, both changes performed on the owner and pet entities are reflected into database. User was not able to cancel out changes made, for example, on pet or owner entities and just let those changes performed in one entity to go into database. Similar cases to such scenarios might also occur when we just add a new pet entity into the owner's collection or just remove an already existing pet entity from the collection as well. It is necessary that all property values or additions and removals from those collections should be stored somewhere else, and so that user changes could be reverted back to their initial values when user decides to cancel out his operation. In the third scenario, I will try to show that new owner entity creation might fail just because of the previous failed creation attempts because of the erroneous or invalid data provided in the system. Here, we just create a new owner. However, user just forgets about entering a required field and just presses create or add button. In this system, there appears an error stating that user should have provided that necessary required fields. And normally, user re-enters data, provides the necessary missing information at its first attempt, and presses the button again. However, this time, our persistence layer just fails because of the state change occurred during the first attempt, because during the first attempt, identifier primary key value assigned to the newly created owner instance, stating detached entity passed to the persist method. Let's try this one as well. Just give some data. Here we see that constraint error appears in the window. In the second attempt, we just correct the error and again press create button. However, this time we see a similar error in our slides, stating that detached object just passed into the persist method. This is because at first attempt, when we call, let's just see our code backing being, save owner, it just calls, create owner, it just calls create owner method, and within that create owner method, we just call persist. JPA persist just assigns an identifier while it persisting that new transient entity into database. However, there happens a problem in the database, and we just the transaction just rolled back. Unfortunately, even though transaction is just rolled back, or that identity is left in the owner entity. In the second attempt, we just provided the missing required field and just resent the owner entity to the persist method again. This time, persist method in the JPA checks that there is a primary key value in the owner entity, and because of the existence of that primary key value, it just thinks that that owner is not transient. Instead, it's detached and raises such an error. Actually, what should have been here, state of the domain object should have been reverted back to its initial values when transaction rolled back at the first attempt, at the end of the first attempt. In the last scenario, I want to mention about the problem related with adding several properties, some properties or methods which are completely unrelated with the domain or business, but only required or necessary for user interface purposes, user interface rendering purposes. For example, we usually place a select column in order to identify which entities are just selected and to keep that selection information in our system, or just for user's perspective, from the user's perspective, just we need to add an additional column to display data in another form. For example, we here just combine first name and last name and present it to our user. However, there is no such a field like full name in our owner entity. Those are only required from the UI layer. They are totally unrelated for our business. And adding such unrelated properties or methods to our domain just pollutes our domain model. Probably we might want to reuse our domain model in another context, and such additions only related with the UI will cause misunderstandings and pollution in our upcoming projects. We should be able to just get rid of such properties and methods. In summary, here, let me, before continuing with the slides, let me just show you those properties. For example, here, we just added select property. However, it is transient. Therefore, it won't be persisted into database, or it won't be populated. Its state won't be populated from database at all. And we also get full name, and it just combines first and last names together. But they are completely unrelated with our business. All those problems arise because of direct binding of persistent domain objects with UI layer. Here, let me show you those bindings. For example, in our owner's XHTML. By the way, this example is just prepared using JSF. However, the problem is not limited with JSF. It can just occur with any other UI technology, with any other data access technology as well. As long as you just fetch data and translate data into domain objects and bind those domain objects to your UI layer. Here, as you see, owners are bound, and each owner property is also bound to UI components. Also, let's look at the owner XHTML. Here, owner first name, owner last name, owner email, which are all coming from the domain object, are just bound to UI components. As a result, persistent domain objects should not be directly used within our UI layer. Instead, there should be a separate layer to handle displaying of such UI-specific information just obtained from domain objects, or grab user input entered in our UI before passing that input to the or domain layer or persistence layer. Our solution here is just based on DTOs, domain data transfer objects. Those DTO objects just placed in between UI and domain layer, and data needed by the UI is first obtained from domain objects and put into DTOs, possibly transformed by those DTOs to make it suitable for UI rendering. Also, user input is first accumulated within those DTOs before letting them to pass to domain or persistence operations. Only they are just flushed or reflected into the target domain layer at appropriate times. However, there might appear a question in your minds that DTOs are just stated as anti-patterns in our community. Actually, DTOs predates back to value object pattern, and they were in enterprise Java were mainly used for transferring data between layers separated by the network. As EGB technologies are mainly used during those old days, and EGB method calls were only removed during those days. Those remote procedure calls were causing lots of performance problems, and people, in order to reduce such performance problems, tried to employ data transfer objects, just combine several objects together, bring several objects together, and transfer data from server to client, or vice versa. Also, many of us criticize DTO because of its violation of dry principle. Because according to dry principle, don't repeat yourself, a task should only be implemented once and only at single place. However, most of the time, many properties and methods in our domain classes are simply repeated in DTOs. Only a few properties, for example, in our example, we just repeated 90% of our properties in our owner, just added 2 more. One is for selection, and the other for is displaying full name. Just because of such little additions, people just don't want to repeat writing domain classes again as a separate layer called as DTOs. As a result, today people mostly consider DTOs as anti-pattern because of such repetition, also because of strong encouragement by several popular UI frameworks like JSF, Vadin, or persistence frameworks like JPA, Hibernate, that shows that it's easier to fetch data using their persistence framework and put that data as domain objects to our UI layer. People usually, as I said, usually fetch data from database using their favorite persistence framework, and they directly bound that data as domain objects with their favorite UI framework, JSF or Vadin, and transferring user inputs over domain objects directly into database has, or vice versa, has just become a mainstream approach in our daily work. In our solution, first of all, we try to get rid of such misunderstanding about DTOs as stating them as anti-pattern. And such a naming with, as DTO or value object itself may cause underestimation to the need of separating UI and domain layers from each other. Therefore, first of all, we just get rid of that naming and give a different name as view model because it just reveals direct relationship with the UI UI layer more than the word DTO. However, violation of dry principle still exists by just renaming the name. We are not able to get rid of violation of dry principle. Here, we employ a unique solution based on dynamic proxy class generation. Instead of coding DTO classes manually, we just implement them, generate them out of existing domain classes dynamically at runtime using proxy pattern. As you know, as you probably know, proxy pattern is one of the mostly used patterns in GOF, among GOF patterns. For example, Spring Framework uses it in order to handle transaction management, bean scoping issues, caching, validation. Hibernate, for example, uses to handle lazy association requirements, and so on. Basically, in proxy pattern, there is a proxy object which just wraps target object. And it just sits between client code and the target object. And client is totally unaware of that proxy. When client sends a request, when a client performs a method invocation, actually first proxy intercepts the method call, performs some pre-processing, and then just lets target object to execute the real method body. When the results is produced, when the method returns, similar thing happens. At that point, proxy can just modify the return value and or do something else and return the result to client back. Why client is totally unaware? Because both proxy objects type and target objects type both extend from same superclass or interface, and our client depends on that interface or super type. There are two possible ways or methods to generate such classes dynamically in our technology. One is to use interface proxy method. In that method, we don't need any third-party library like CGLib or Java Assist. JDK itself just provides the enough infrastructure for this purpose. Within the reflection API, we can easily generate a proxy by just implementing any interface which is also implemented by our target objects class. The important part is that our target object class should also implement at least an interface. In this method, we need to extend from a class. This is called as class proxy, and we need a third-party library like CGLib, or Java assist. And indeed, in our solution, domain classes without implementing any interface are just extended, and proxy classes are just created with this approach. In the end, we also need a separate complete API in the role of a bridge between UI and persistent domain objects, because we need to handle data manipulation operations in between. For example, when we place proxies between UI and domain instances, for example, user input first will be accumulated in the in those proxies, and they should they have to be transferred to target domain instances at appropriate times, or data need to be fetched from those domain objects and transformed and then delivered to UI layer. Therefore, we specified an API or view model API. Let's quickly skim over the methods, available methods in that API. First one is get model. This method just delivers, gives us the opportunity to access wrapped target domain instance. Flash helps us to reflect changes accumulated in the proxy to the wrapped target domain instance. Refresh, on the other hand, just reverse state of the view model or proxy into domain model's initial state. Save point or rollback with identifier input allows us to save current state of view model by associating it with an identifier, so that view model state can be just rolled back to the state of that identified state at a later time. Is dirty can be used to detect if current view model state has been changed or not. For example, in order to identify whether or user just performed a manipulation on the UI, whether UI is changed or not, UI state is changed or not. Selected or set selected methods helps us to identify if view model instance is selected or not in the UI. Transient to check if domain instance is transient or persistent. In other words, it is just persistent in the database and has a corresponding record in the database or not. Replace to replace given domain instance as a parameter with the old value which is wrapped in the view model instance. Added elements helps us to identify which collection elements are added into our collection property identified with the given property name. Removed elements is similar, but just to identify removed elements from the collection. Which elements are removed from the collection? Dirty elements, in order to identify which collection elements are just modified in our collection. For example, owner pets collection, if there are pets newly added or removed pets, old pets which are removed, or modified pets, in order to identify such objects, we can just use those methods. In the end, let me show you how such how our API is used in action. Here I put some code snippets just to focus on how our API is just used. For example, in our first scenario, when we list owners, we just fetch owner entities from database using JPA, executing this query from owner, and we just iterate all those owners and convert them into the view model instances using view model creator, which is a utility being in our system. It just takes the type and wrapped domain instance and returns view model instance, which is also another owner instance. And we just bind those owner view model instances in our UI. When we select and try to edit an owner, we can just iterate over those view model instances and try to identify which one is selected by calling is selected method in our view model. We just downcast from owner to view model interface type and call that special method. When, for example, in the owner detail tab, when we perform some changes here, we perform that changes, but that change is just accumulated in the proxy view model instance. Here, when we click the tab, owners tab, in order to switch into pets tab view, we just create a save point with that identifier. At that point, we create just a snapshot of the view model state. And in the pets tab view, we select a pet and identify which one is selected. Again, calling is selected method. But here, pets are also view models. When we create owner view models, our view model creator just identifies that pets are also need to be wrapped by the view model instance as well. In the edit pet dialog window, when we click cancel in order to revert back to our initial state, we just cancel, and in the backend we just call rollback method of the view model by giving the identifier we just created previously here as calling save point. If we want to reflect changes accumulated in the view model, for example, only the changes in the owner detail view, ignoring changes made in the pet view, we just call, for example, selected owner flush to reflect changes from view model to owner instance, target domain instance, and perform transaction commit. Let me show you, before going further, let me show you how it works, really works. I will just stop in order to reinitialize database and restart the system. Yes, let's follow this time the second path with view model. Again, we click edit and perform a change in the owner. Now, I just click pets tab. At that point, I want to look at the database. For example, as you see, there is no change reflected in the database. I click Edit Path dialog, perform some changes, cancel the operation, switch back to owner detail, press Update button, and see what happened in the database. As you see, no change reflected in the pet entity. Only our owner instance is changed in the database. Let's try creating a new owner. Here, I just try to create a new owner. I got the same error. Provide necessary missing information and press create button. This time we are able to insert our new owner in our database. When we try to list owners, they are all listed. Also, it exists in the database as well. Yes, third one is also appears in the table. Before finishing, let me just mention about how can we add additional properties or methods which are only required by our UI layer. They are not required by domain or business perspective. They are just necessary parts for our UI. Here, we just define a new, declare a new interface with the necessary method and a default implementation with this interface. Here, within the default implementation, we can just access the model by calling get model and deal with the necessary job. As you remember, we have already added is selected and set selected methods because they are so common that we almost always need such to track such selection information in our systems. Then we just need to register this newly defined view model interface and implementation in our system. Unless we do extend or add new methods to our view model, we don't need to perform this step. However, as we created a new view model specific method, we just created this view model definition and registered it in our system. In conclusion, as we stated in this presentation, reusing persistent domain objects in the UI layer directly causes several data integrity problems, as I tried to show you by examples. An intermediate layer, extra intermediate layer, is just placed to remedy those problems, and a separate API is just required to execute operations necessary to deal with data manipulation tasks in that intermediate layer. And such a separate layer based on DTOs can easily be developed and created based on dynamic proxy generation techniques. Here my presentation ends. I hope it becomes useful for your daily job. At that point, we can you can ask your questions if you have. If you don't, thank you for listening.